How to design your structural equation model using SmartPLS 4. Here we are going to start with importing the data. So we are going to go to new project. Then I will just name this as PLS-SEM, like this, PLS. Just give it a name like that, create. And then I go to import data file and click this and go to the folder where I have the data. So on this desktop, and I will put this and click open. Here it is. So once I import it like this, I can just see that the scale here is metric for most variables. In case I have missing values, it's very important I should define them by including a number like this minus 99 and apply a marker. You see here it turns out to be green, so it's very important to do this step. Next I click import, and then I have the data. Suppose that you missed doing that step, or you had the data already done, you could just go to setup here and you could redo this step again from here, so it's fine. So then I just cancel this and I go back, and here once I have the data imported, I could just right click and I choose which model I would like. So in case I want to test the reliability and validity of the model, I could just choose the new PLS-SEM model is here. So let's just test the reliability and validity along with the hypothesis. I will just click this, and then I will just call it this, and here it is. So now I need to start putting the items or indicators or observed variables here to form the latent constructs. So I need just to click control and then I need to keep checking the or command and then checking the items like this till I finish. Suppose this is the first construct, so I will just drag and drop here and I call it, for example, motivation, and click OK. So this is the first variable. I could just drag it like that. I could make changes from here depending on the places where I want to have the indicators. So for now, let me just do it like this. And we start the model from left to right. So this is very important. So we start from the IVs or the independent variables to the dependent variables, and in between we have mediators and moderators. So here we could just include the dependent variable. Let's say school achievement. I could choose one by one, or sometimes I could just choose everything like this. So depending on the shortcuts, you use Alt and Shift, etc. So I will just drag and drop again here. We can call this performance, school performance, and click enter. That's it. So these are the two variables. I can just draw an arrow that indicates the impact or effect of motivation on performance. So here I will just click connect and then draw an arrow like this. So here there is an impact of motivation on performance. So this is one simple model. Suppose I want to add a mediator. Let's say that motivation impacts performance with the mediation of study hours. Like the more motivated people are, the more time they spend doing a task, and that will increase their performance. Okay, so here I could just include the mediator variable. So here, these are the items that form the mediator. So we could call this time spent, and click enter. And I need to go to the arrow and just choose an arrow from the IV to the mediator, then from the mediator to the DV or performance, like this. So this is like the model that we have of mediation. Suppose I have a moderator, let's say interest, etc. So we can have a moderator like this. It depends on our model or theory. So here we could just have moderator, this one. So we can put them here, and we call this, for instance, interest. And then I can just connect this interest with the performance, and then I need to click the moderating effect and drag an arrow like this. So I could just do the moderating effect, and the same I could just have an arrow from the interest to the performance. So it depends. Suppose that I want to delete this, for instance, and then I will go to the moderating effect and I will do something like this. You see, so this is the moderation and mediation model. This is like how we can design it. And it depends on the complexity. In case we have higher order constructs or lower order constructs, we can plot them in a different way. Suppose that motivation is divided into intrinsic and extrinsic. What we need to do is that we need to put intrinsic motivation alone, extrinsic, and then we draw the arrows. And then the same for this one, motivation will be created. It will not be, let's say, an observed variable. So we will create it, and then we will import the items that correspond to the intrinsic and extrinsic motivation to it, so that we can see that. And the arrows also, depending on their direction, we can have what we call a reflective measure like this, because the arrows are reflected from the latent construct to the indicators or observed indicators. Or we can also have what we call the formative measure, in which the arrows can be reversed like this. So like they can come from the indicators to the construct. To form that, like measurement here, you see that it's reflective. We could make it formative. Click apply, and you see here the arrows direction have changed. Double click, and then we can make it reflective. So there is this distinction between formative and reflective. For formative, we cannot delete those items. For reflective, we can delete that. Also, for reflective, we just use, for example, some statistics like loadings, whereas for formative, we use weights, etc. So there is this difference between formative and reflective. After designing the model, the first step is that we need to test the reliability, validity, and the other quality criteria. So to do this, we need to go to calculate and then a PLS-SEM algorithm, and then click start calculation, and here they are. So if you check quality criteria, you will find, for example, the R square, the residuals. This is for what we call the nomological validity. So here we could just see the residual and see the correlations, and see if there are some negative correlations that between the items and the construct that they refer to. We could assume that there is negative coding or reverse coding. So this is for the outer model. The inner model, again, we could check the correlations, and depending on that, we could check what we call nomological validity. Then we have the R square. So the R square is about the impact that is explained by the predictors in the dependent variable. So this is what we mean by the R square. So here the R square is positive, and there is more than 70% of the variance explained by the predictors as far as the two dependent variables, or what we call endogenous variables, are constructed, because the R square concerns only the dependent variables, not the independent variables. The F square as well can be used here. We can report it. Sometimes some values have negative F square. Then we have the construct reliability, in which we check the Cronbach alpha reliability, the average variance extracted, etc. We could just have it in a table like this. All the, let's say, values appear in green. The threshold here is 0.7 here, which is good. And the threshold here is 0.5. So here it's good. So the Cronbach alpha reliability tells us about the internal reliability of the items in each scale. And the same for the average variance extracted, the this issue of convergent validity, like how items converge together to form a scale. Then we have average variance extracted as graph, etc. separately. And then for the discriminant validity, we have three types. We have the heterotrait monotrait ratio. Everything that is in green is good, so there is a threshold, like everything that is in terms of the heterotrait monotrait ratio, which is 50%. Then for the Forna-Laka criterion, it simply means that those numbers here should be greater than the sum here, and the same for here. Like, for example, this number should be greater than this, and all of these. This means that this variable or this construct, which is called performance, should have discriminant validity. It means it should be distinguished from all the other constructs. It should not be similar to them. That's why its correlation should be higher than the others. So this is called the convergent validity. Then we have the cross loadings, which are very important to report. And then we have the collinearity statistics through the VIF, or what we call the variance inflation factor, and it ranges between 3 and 5. So here there are some issues with regard to multicollinearity in some items. That's why in red, this can be an issue here in this model. It means that some items are really similar to each other. This is what multicollinearity means. It means that there is some redundancy in the items, like they are repeated, and that could inflate the results. Then we have the inner model list. So this is like another multicollinearity, because we have multicollinearity for the measurement model and multicollinearity for the structural model, or the inner model we call it. That's it for this. For the path coefficients, we need to just run another algorithm, which is calculate, then bootstrap, and then we choose here 5,000, or in case of publications and research, we choose 10,000. It depends on the algorithms. So let's just keep that 5,000, and we keep everything like in default. Here for the type, the test type, the two-tailed depends whether we have all hypotheses having, let's say, a direction of the impact like positive or negative, etc. Then we click start calculating. So this is the output. So here I could see the path coefficients and p-values. You could see, for example, that motivation impacts time spent by 81%, which is statistically significant. And then it impacts performance by 27%, which is also statistically significant. And then time spent impacts performance by 30%. So you see here why we include mediation or mediation effect. So the impact keeps changing. Again, here we could see also the impact of the moderation here, and it is statistically significant. It's 37%, and there is this one here which is 5%, but maybe not statistically significant based on the p-value that is greater than 0.05. That's it. So this is like the for the outer model, we could see the outer weights and loadings and p-values, and here they should be not less than 0.5. If we find that they are very small, like 0.5 or 0.6, we could delete them depending on the threshold that we adopt, and depending on the strictness of the criteria that we want to include here. This means that those items perfectly load here, so there are no issues, and you could just see them here, etc. So this is in brief how we go about the path coefficients and running the model. We could see the results from here. So these are the tables. This is the beta coefficient, this is the p-value, this is the t-statistics, and these are the standard deviations. So what we need from this table is just the beta coefficient, that is the regression beta, and the p-values. That's it. And this is for the mediation. We have the total indirect effects. You could see it here. Motivation and performance, has this total indirect effect of 24%, which is statistically significant. And then we can also see the confidence intervals, etc. The specific indirect effects, you see that there is this impact of motivation on performance with the time spent in between, and it is still significant by 24%. So, and then we have the total effects, and these are like used mostly for mediation and moderation as well. So here you have the beta coefficients. You see that the moderation effect is not significant, whereas for the others they were significant. You see, so these are all of the different effects that we call total effects. Then we could see the R-square. Here it's absent because we saw it in the PLS-SEM, so it's not available here. The same for model fit criteria, so they are not available, but we saw that in model SEM. The last step is to do what we call PLS predict. So we can go to calculate, then we can go to PLS predict, this one, and then run this in default and click start calculating. So for this variable prediction, for the PLS predict, so we have this q square predict, which is good. It should not be 0. So here it's 5, which is good. And we have this MEA and LMA, linear model, RMSE, etc. What is important is this one, q square predict. It just tells you that your model can predict future events, like so it has this predictive power. Of course, these other values are also important, but they require more details. I can share with you some definitions in the description box so that you can check, because there is a way to report them in structural equation modeling. So this is in brief how you can run a structural equation model and interpret the results. If you have questions or remarks, do not hesitate to post them below, and see you soon. Bye for now.